As you can see here, I've already created a chart of all of the codons that could code for their respective amino acids. When we get to phenylalanine, it could either be coded by UUU or UUC. And we can also see that the mutant gene is where our sequence begins to change, whether there's an addition or a removal of a base within the sequence. We figured this out by seeing that in isoleucine, it's now AUU, whereas in phenylalanine, it was UUU. In our mutant, the next amino acid is histidine. Histidine starts with a C, and threonine, the middle base, is a C. So you might think there is a deletion in phenylalanine, moving the C into this A position. However, that's not the case, because when you look, while this could be a CA, which would be the same as here, it cannot be CAU, because then from this lysine, there's an extra A. So it would be, even if this last U was an A instead, it would be CAA, not CAU like we want. So from this, we have to conclude that there is an addition. An A is inserted in the first U in phenylalanine. So the code would go UGG, A, U, U. And because we know the next letter has to be C, then phenylalanine is actually UCC rather than UCU. And that would account for the C in histidine, which would then be CAC. This is why we have to set up this table so that we can see all the variants of the codon. It wouldn't work if histidine was only coded by CAU. Now, after these amino acids, there will be stop codons, which could look something like UAA. And we can see here that UAA does exist from the addition of this A base. And so that allows for the creation of the stop codon. And it truncates the normal protein and creates the mutant truncated non-functional protein that we see here.